In this video, I'll show you the solution to problem 6 of exercise 10B.1. This is the pole problem, and it's the most difficult problem in the section. Now, if you've read through the problem, you understand that there's a man or a woman standing on the bank of a river, and they're looking directly across the river at a perpendicular line or line of sight to pole A. And just down the stream or down the river from pole A is pole B, and those poles are separated by 100 meters. It's also given to us, and this is very important, that the poles are exactly the same height. Now we're also given the angle of elevation to the top of pole A from M, and that's 22, and we're given the angle of elevation to the top of pole B from M, which is 19. And we're asked to find the width of the river, or in other words, the distance between points M and A. The key to this problem, as you may have guessed, is to use right triangles. In fact, we need to draw 3 right triangles. And I'm going to do my best here to represent this in 3 dimensions. Right? This is the angle of elevation from M to the top of pole A. And we know that that is 22 degrees. And we have line of sight from M to the top of B. And I can draw a line from M to B. And then I have that angle of elevation, which is 19. So I have 2 right triangles there. And I also have a third right triangle, which is flat on top of the river. And that goes from point M to A, from A to B, and from B to M. And the right angle in that triangle is at A. So it's really useful to draw those 3 triangles. So I'll start with the triangle MBA. Okay, and I'm going to label those vertices. That's really important. I know that that's a right angle there, and this is 100 meters. And that's really all I know about this triangle, but what I'm trying to find is the length MA, so I'll label that X. Now I have 2 other right triangles. I'll draw MB and pole B first. Right, and again I'm going to label this MB, and then this is pole B. And likewise, I'm going to have another triangle, also point M here, point A here, and pole A. These are both right triangles. And I don't know much else about them. I do know these angles, the angles at M, and for this triangle that's 19 and this is 22. Right? I don't know the distance between M and A, but that's the same M and A that's up here, and we've already labeled that X. So I'm going to go ahead and label that one X. Right? And I don't have a variable for this length, which is BM. And you'll notice that shows up twice as well. So let's give that a variable. We'll call that Z. And remember from the beginning of the problem that the poles are exactly the same height. And again, I don't know what the height is, but since they're the same height, I can give those both the same variable, and we'll call that Y. Okay, so this problem, it looks like it's getting a little complex. And you'll notice that we have 3 different variables. We have X, Y, and Z. And remember that X is my goal here. This is what I'm trying to solve for. So I need an equation to solve for X. And I'm going to go back to my trigonometry equations, cosine, sine, and tangent, to help me try to find X. And so let's do that now. We make a little more room here. And I'm going to call this triangle 1 right here. And from triangle 1, we can write an equation that involves both X and Y and the known angle, which is at point M. So I have the opposite side and I have the adjacent side. So that's tangent. Therefore, tan of 22 equals y over x. Okay, I can do something very similar from this triangle right here. Right, and hopefully you can see that tan of 19 is equal to y over z. And I have one more triangle, this triangle up here, which we'll call triangle 3. And I can write an equation here, and I'm actually not going to use a trig function, I'm going to use the Pythagorean theorem. And you'll notice that I have the two sides here and the hypotenuse. So we're going to write that out as 100 squared plus x squared equals z squared. Now what I've done here is I've written three equations, and there are three unknowns, x, y, and z. This is a system of equations, and we need to solve these equations simultaneously. So I'm going to start with the first two, and I'm going to rearrange both of those to solve for y, because y appears in both those equations. So I just simply multiply the first equation by x on both sides, and we get y equals x tan of 22. And in the second equation, I'm going to get y equals z tan of 19. Now since these are the same y's, I can set the right-hand sides equal to each other. So we'll go ahead and do that. And that gives us an equation x tan 22 equals z tan of 19. So now I have an equation that's written in terms of x and z. And if you go back to the third equation that we wrote over here with the Pythagorean theorem, you'll see that we have an equation in terms of x and z. So what I've done is I've cut this down from three simultaneous equations to two simultaneous equations. I have two equations, two unknowns, and now I can solve I can use substitution to solve for x. Now since I want to solve for x, that means I want to get rid of z here. So I need to find something to substitute in for z. Which means in this equation over here, I'm going to solve for z. And to solve for z, I simply divide both sides of the equation by tan 19. Okay, so I have z equals x tan 22 over tan 19. Okay, so far not so bad. We're going to take that expression for z and we're going to plug it in here. Okay, so I'm going to write my final equation here, which is 100 squared plus x squared equals x tan of 22 over tan 19, and don't forget to square this whole thing because this z up here was also squared. So this is my final equation. Now I have one equation, one unknown, which is x. This becomes an algebra problem. I just need to solve for x here. So the first thing I'm going to do is subtract x squared from both sides. So we get 100 squared equals, I'm going to do a little bit of rearranging here, tan 22 over tan 19 squared times x squared, right? Because I can distribute this exponent into the parentheses. Okay, minus x squared from the other side of the equation. And now I have an x squared on both terms here, so I can factor out an x squared. So I have 100 squared equals x squared times tan 22 over tan 19 squared minus 1. We're almost there. Now I need to get x squared alone, so I'm going to divide both sides of the equation by this huge thing right here. Okay, and I'm going to rearrange so that x squared is now on the left, so we get x squared equals 100 squared divided by tan 22 over tan 19 squared minus 1. And the last step to get x alone is just to take the square root of this thing right here, right? And that's going to give me x. Now you'll notice that I didn't simplify anything ahead of time. I didn't convert to decimals. You could have figured out what tan 22 over tan 19 was if that really bothered you. Just convert that to a decimal. But then you're approximating, right? So what I've shown you is the exact solution. And this is what you can plug into your calculator to get the number that goes into JunoEd. So I'm not actually going to calculate this out for you. I think that's good practice to do a solution and get the exact solution. You can practice putting this in your calculator and plugging it into JunoEd to see if you got the right thing. That also makes you have to watch the whole video to understand what's going on here. So this is the solution, and go ahead and simplify it. If you have any questions, ask me in class.